Everything we thought we knew about the moon, I now believe is wrong.
Forward. Forward. 40 feet down, 2.5. Picking up some dust. Great shadow. I'm going to step off the limb now.
And I don't say that lightly. For 53 years, ever since Eugene Cernan kicked the last footprint into the lunar dust in December of 1972, we've operated on a quiet assumption that the moon was a finished story, a gray, dead, mapped, mineralogically boring rock that we already understood. Then on April 6, 2026, 4 people in a metal capsule swung around the back of it, and in the span of about 7 hours, that assumption fell apart on live audio. I spent the last few days going through the downlinked transcripts, the GRA gravity data from 2019, and the Chang'e 6 sample reports from 2024. And what I want to walk you through in this video is not the press release version of the Artemis II flyby. It's the version where you start asking questions NASA hasn't fully answered yet. The crew is Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, and I want you to hold those names in your head for a second, because what they did is genuinely unprecedented. The first woman, the first black astronaut, and the first non-American to ever leave Earth orbit, all on the same vehicle at the same time. That's not a footnote. That's the entire post-Apollo era getting rewritten in one mission patch. They lifted off from the Kennedy Space Center at 6:35 p.m. Eastern on April 1st, 2026, sitting on top of the Space Launch System, 322 feet of rocket producing 8.8 million pounds of thrust at the pad. A single burn under 5 minutes long is what threw them out of low Earth orbit. After that engine cutoff, there was no realistic way to come back early. They were committed. Now here's a detail that I find quietly terrifying, and most coverage skipped right over it. The trajectory NASA chose is called a free return, meaning if every engine on the Orion spacecraft died the moment after that burn, the moon's gravity would still loop them around and fling them back toward Earth on its own. Apollo 13 used the same kind of path in 1970 after their oxygen tank exploded. This is the safest available route to the moon in 2026. Read that sentence again. The safest option we have, more than half a century after Apollo, is the one engineered around the assumption that the engines might not work. That tells you everything about how unforgiving this still is. They came around the far side at roughly 4,067 miles above the surface, and for 40 minutes, the moon itself stood between them and the entire human species. No telemetry, no voice loop with Houston, no abort capability, just 4 heartbeats inside a pressurized can and the most ancient terrain in the inner solar system rolling past the windows. Glover tried to narrate it before the blackout cut him off. He couldn't get the words out. His exact phrasing on the loop before the signal dropped at 6:44 p.m. Eastern was that humans probably haven't evolved to see what they were looking at. That's a Navy test pilot talking. These are not people prone to poetic exaggeration. So what was actually out there? To get why this matters, you have to understand that the far side is not just the back of the moon. It is, in almost every measurable way, a different world from the face we see at night. The near side, the one painted onto every children's book and tarot card, is about 31% covered in dark volcanic plains called Maria, basalt seas that flooded out of ancient impact basins billions of years ago and froze flat. The far side has less than 1% of that. None of the calm, none of the smoothing, just craters punched into older craters, going back 4 billion years with no reset button. And the asymmetry runs deeper than the surface. The crust on the far side is roughly 50 kilometers thicker than on the near side, and there is still no consensus explanation for why. The leading theory points to one specific event, a massive impact near the lunar South Pole so violent it pushed heat through the entire interior of the moon, shoving radioactive material and rare earth elements toward the near side. That impact left a scar called the South Pole Aitken Basin. roughly 2,500 kilometers wide, up to 13 kilometers deep. If you laid it on top of the United States, it would cover everything from Texas to Virginia. The mountains along its outer rim crested around 8,500 meters, taller than anything in the continental US. And underneath the floor of that basin, something is hiding. In 2019, Peter James and his team at Baylor University cross-referenced gravity readings from NASA's Grail mission against topography from the Lunar Reconnaissance Orbiter, and they found a mass anomaly buried at least 300 kilometers down. Minimum weight, 2.18 quintillion kilograms. James himself compared it to burying a slab of metal 5 times the size of the big island of Hawaii under the surface. It is heavy enough to physically warp the basin floor downward by more than a half mile. The most plausible explanation, and I want to be clear that this is the leading hypothesis and not a confirmed answer, is that it's the iron-nickel core of the asteroid that carved the basin in the first place, still embedded in the mantle 4 billion years later, like shrapnel the body never expelled. And the Artemis II crew became the first people in history to look at the eastern edge of that basin with their own eyes through a window, not through a robotic camera feed, not through processed orbital data. Direct line of sight. The Apollo guys never had it. Their flight paths and their solar lighting angles were wrong for it. This trajectory was deliberately engineered to expose roughly 21% of the far side to direct sunlight from the crew's perspective, enough light to actually see features that no human had ever personally witnessed. One of the 30 science targets on the flight plan was the Oriental Basin, nearly 600 miles wide, about 3.8 billion years old, sits right on the boundary between the near and far sides, and from orbit it looks like a cosmic bullseye that someone drove into the western edge of the moon. The crew had spent months training in the volcanic terrain of Iceland to learn how to describe geology in real time, because none of them are professional geologists, they're pilots and engineers. And Christina Koch, looking down at the freshest, youngest impact craters scattered across the older surface, said they were shockingly bright. She compared them to pinprick holes in a lampshade, tiny, glowing white, set against dull gray terrain. Before they reached the far side proper, they also got eyes on one of the moon's strangest features, Reiner Gamma. It's a bright, swirling pattern smeared across the near-side surface like someone dragged a paintbrush dipped in white across dark stone. It has no elevation. It is not a crater. It is not a volcanic deposit. It is, as far as we can tell, an optical phenomenon that lines up exactly with a localized magnetic anomaly in the crust beneath it. And here's the part that should stop you. The moon has no global magnetic field. It hasn't had one for billions of years, but scattered across the crust are these patches of magnetized rock, fossils basically, of a field that died a long time ago. Reiner Gamma sits directly on one of those patches. We still don't know if the magnetism is shielding the surface from solar wind weathering or if something else entirely is responsible for that swirl. Glover, the pilot, became fixated on the terminator, the moving line that separates the lit half of the moon from the dark half. Along that line, craters change character entirely. The sun hits their rims at a knife-edge angle, and the shadows they cast look bottomless. He radioed down that the terminator was full of magic, that the dark valleys looked like black holes you could fall straight through to the center of the moon. While he was on the terminator, Koch and Hansen were photographing the Vavilov crater, which sits perched on the rim of the older and bigger Hertzsprung Basin, deep on the far side. The science evaluation room in Houston was rewriting the observation plan in real time, sending updated targeting based on what the crew was seeing through the windows. That's not how Apollo worked. That's something new. And the crew kept reporting color, subtle browns and greens on the near side, faint blue tints in some regions, color nuance that the human eye can pick out, but that orbital cameras tend to wash flat. This is not a cosmetic detail. Color shifts on the lunar surface map directly to mineral composition and to the relative age of features. The crew may have just handed planetary scientists a dataset that orbital imagery could never give them. And here's where the story turns from beautiful to genuinely unsettling. In 2023, researchers identified a thermal anomaly under the far side, about 50 kilometers wide, roughly 10 degrees Celsius warmer than everything around it. The most likely source is a buried block of granite. Granite on the moon. That should not exist. Granite on Earth requires water and plate tectonics to form, and the moon has neither. Lead author Matt Siegler, in his own words, said, "It looks far more like something we'd see on Earth than anyone thought was possible up there." The team's working theory is that it's the dead core of a volcano that went silent 3.5 billion years ago, with residual magma still glowing faintly underneath, which leaves us with a question I don't think anyone expected to be asking in 2026. What else under there is still warm? And then there are the lava tubes. Radar and high-resolution imagery suggest the moon is hollowed out by underground tunnel networks left behind by ancient lava flows. Some of the entrance pits are visible from orbit. A few of them appear to lead into caverns large enough to fit entire structures. We don't know their true size. We don't know how stable they are. We don't know what's inside them. Pristine volcanic deposits, trapped gases, temperature regimes radically different from the surface because we have not been inside a single one. They are sealed for now. And I want to flag something here because this is where speculation usually runs ahead of evidence. I have seen people online over the past few days claim Artemis II discovered alien structures or buried bases inside those tubes. They did not. There is zero credible evidence for that. The actual scientific story is strange enough on its own merit. We don't need to invent a Marvel plot to make it interesting. The crew also witnessed something no human had ever seen from that distance and that angle, a total solar eclipse from lunar orbit. As Orion swung behind the moon, the sun slid behind the lunar disk and went dark. Totality lasted nearly 54 minutes, far longer than any eclipse you'll ever see standing on Earth. The sun's corona, its outer atmosphere, flared into a halo bright enough, in Glover's description, to ring the entire moon. Hansen reported that the corona was lighting up the full perimeter, silhouetting ridges and peaks along the lunar limb against burning white light. And then both Hansen and Wiseman reported something that I want to be careful with. During the eclipse, they saw what looked like brief impact flashes on the surface, sudden bursts of light, possibly small meteorites striking the unprotected far side. Houston asked for clarification. Both confirmed at least one. Neither could put a duration on it. This matters because the moon has no atmosphere to slow incoming objects, no magnetic field to deflect particles. Every micrometeorite, every solar wind ion, every cosmic ray hits at full speed. For centuries, observers on Earth have reported transient lunar phenomena, quick flashes that appear and vanish before anyone can confirm them. Some are likely impacts, some might be electrostatic dust plumes, some might be outgassing from a moon that we keep insisting is dead. Nobody has a definitive answer. The Artemis II crew may have just added the most credible witness account on record to that ongoing mystery. And speaking of things hitting the spacecraft, this is the part of the mission that doesn't get enough attention. Some of the Apollo astronauts reported seeing flashes of light behind their closed eyelids during their flights. The cause was high-energy cosmic ray particles physically punching through their retinas. Their exposure was a few days at most. Several of them later developed cataracts at unusually high rates. The reassuring part is that most Apollo astronauts went on to live long lives without obvious radiation-linked cancers. The unreassuring part is that the entire sample size of humans who have ever left Earth's magnetic protection section is exactly 24 people. That is a statistically meaningless dataset, and we're about to start adding to it. Artemis II is spending 10 days in deep space during what's called solar maximum, the peak of the sun's 11-year cycle, when the risk of a major solar particle event is at its highest. A severe solar storm can deliver near-lethal radiation doses in a matter of hours. Orion has more shielding than Apollo did, but galactic cosmic rays, the stuff originating from supernovae and neutron star collisions, move at near light speed, and they punch through almost anything we currently know how to build. Alexandra Stankovic, who runs the Center for Space Medicine Research at Massachusetts General Hospital, has called deep space radiation the single biggest limiting factor on how far humans can go, the showstopper in her exact word. Researchers right now are testing experimental drugs, dietary protocols, and even speculative gene therapies borrowed from radiation-resistant microbes, because the engineering solution alone is not going to be enough. Biology has to meet it halfway. And tucked inside Orion on this flight is a payload called Avatar, bone marrow cells cultured from the crew's own blood. After splashdown, scientists will study how those cells responded to the deep space radiation environment in real time. That dataset, frankly, is worth more than all the photos combined. Now, I want to come back to those 40 minutes of communications blackout, because I think the gravity of it gets lost. During that window, the crew was beyond help. If a solar particle event had hit during the blackout, Mission Control would not have known until the signal came back. The crew trained for it. They had pressurized suits. Orion was set to maintain cabin pressure on its own. None of that changes the actual reality of the moment. 4 people inside a capsule about the size of a large van, separated from the rest of humanity by 2,160 miles of solid rock, surrounded by terrain shaped by 4 billion years of unfiltered cosmic violence, soaking in radiation that our species did not evolve to handle. That is the version of the story you don't get in the press conference. And then the signal came back. Houston erupted. The crew said they had just watched Earth set behind the moon, a slow disappearance of a pale blue crescent slipping behind gray cratered rock. NASA released the image. They're calling it EarthSet. It's a deliberate mirror of the Earthrise photograph that Bill Anders took from Apollo 8 in 1968, except this one is the inverse. Earth is leaving, slipping out of view behind the far side, vanishing. Christina Koch, in a moment that genuinely cut through the technical chatter, said that when you have that perspective and you compare it to home, it reminds you how much we have in common, that everything we need, Earth provides, and that you can't really understand that until you've seen the other side. The crew named 2 craters during the flyby. One they called Integrity, after their nickname for the Orion spacecraft itself. The other they called Carol, after Reid Wiseman's late wife, Carol Taylor Wiseman, who passed away in 2020. It sits right on the boundary between the near and far sides, and it's bright enough to see from Earth if you know exactly where to look. Hansen described it just as a bright spot on the moon. Sometimes the simplest description is the right one. By the numbers, Artemis II set the record for the farthest any human has ever traveled from Earth, an estimated 252,756 miles. Closest approach to the moon was around 60,863 miles per hour relative to Earth. Total flyby observation window, about 7 hours. They took thousands of photographs. Most of them have not been downlinked yet because of bandwidth limits. The full set won't arrive until after splashdown, scheduled for Friday, April 10th off the coast of San Diego. And those images are going to matter for reasons that go beyond pretty wallpaper. NASA has said the photographs of craters, ridges, and ancient lava flows could reshape how we understand the moon's formation, how the early solar system evolved, and where we should send the next set of missions. The crew's real-time descriptions of how shadows behave along the terminator, how surface textures shift in different lighting, are going to feed directly into landing site selection for future Artemis crews. A site that looks flat and inviting in an orbital photo can look genuinely treacherous when a trained human eye watches the way shadows pool around it. And here's where I want to widen the lens, because the far side is already contested ground. Not militarily, not yet, but scientifically. China's Chang'e 4 lander touched down on the far side in January 2019, inside the von Karman crater, a 186-kilometer feature on the floor of the South Pole Aitken Basin. First soft landing on the far side in human history. They had to park a relay satellite called Qichao in a halo orbit beyond the moon just to keep a radio link alive, because direct Earth communication from the far side is physically impossible. Their Yutu-2 rover found olivine and pyroxene, minerals from the lunar mantle, confirming that the South Pole Aitken impact dug deep enough to throw up material from hundreds of kilometers below the crust. Then in 2024, Chang'e 6 went one step further. It collected samples from the far side and brought them back to Earth, the first time material from the moon's hidden hemisphere has ever been pulled into a laboratory. Scientists are still working through that haul as I'm recording this, and the far side offers something else that no other location in the inner solar system can: radio silence. It is permanently shielded from the electromagnetic noise of human civilization. Every cell tower, every Wi-Fi router, every broadcast, all of it blocked by 3,400 kilometers of solid rock. For radio astronomy, the far side is the cleanest listening post that physically exists. A telescope placed there could pick up frequencies below 30 megahertz that Earth's own ionosphere blocks. That opens a window into the very early universe that we have literally never had access to. Multiple space agencies have already proposed building observatories there for exactly that reason. The moon isn't just hiding things on its surface, it's offering us a tool to hear the rest of the universe more clearly than we ever have. And this is the part where I want to push back on the way most of the coverage is being framed. We have spent centuries staring at one face of the moon and calling that face the moon. We landed 6 times during Apollo. We collected rocks from a handful of deliberately chosen sites, all on the near side. And from that local sample, we built a model of the entire body. That is, scientifically, the equivalent of landing in the Sahara and concluding that the entire planet Earth is made of sand. The far side is where the real story has been hiding the whole time. A landscape so ancient and so battered that it preserves impacts the near side erased under lava billions of years ago. A basin so massive it may have physically shifted the moon on its rotational axis. A metallic mass buried so deep it warps the local gravity, heat sources we cannot fully account for, sealed lava tubes we have not entered, a crust so different from the near side that it breaks the basic models of how moons cool and solidify. Glover, after Orion cleared the far side and Earth came back into view, said something simple. He said, "The moon is not just a poster in the sky that goes by. It's a real place." He's right. And I'd add this: the more we learn about it, the less comfortable that fact becomes. Because the far side is not just different from what we expected, it is different in ways that keep forcing us to rewrite the story. Granite that shouldn't be there, a mass that doesn't fit any clean theory, an asymmetry that no single hypothesis fully explains, magnetic ghosts in a crust that lost its field billions of years ago, and those moonquakes that the Apollo seismometers detected, shallow tremors recorded for years, suggesting that something is still moving inside a world we have spent 2 generations describing as dead. Every answer the far side gives us opens 3 more questions, and those questions keep getting harder. Here's my prediction, and I want to be on record with it. By 2030, I think we will have confirmed at least one major active geological process inside the moon that current models cannot account for. Either residual volcanic heat under that granite anomaly, ongoing tectonic activity tied to the South Pole Aitken mass, gas, or a mechanism for the magnetic patches we still can't explain. I think the dead moon model dies this decade. You can hold me to that. The Artemis II crew is on their way back as I'm recording this, falling toward Earth at thousands of miles per hour. They splash down on Friday, and when they do, they bring with them the first direct human observations of the moon's hidden face in over half a century. Not the cleaned-up version from orbital cameras, the version that made Victor Glover, a Navy captain, a test pilot, 168 days on the ISS, say on the loop that what he was looking at was beyond what humans evolved to see. The moon is not what we thought it was, and we have barely started to find out what it actually is. I'm Mike. See you in the next one.